Alright, so in this problem we have a 52 kilogram circus performer who is sliding down a rope, which will break if the tension exceeds 425 newtons. The question is, what happens if the performer hangs stationary on the rope? So let's first check the forces that we have. So we've got basically a rope and someone is hanging to it. Now, the forces that will be acting on this performer are basically the weight, which is downwards, and the tension, which is upwards. We are told that if the tension exceeds 425 newtons, then this rope will break. Let's check the value of the weight of this performer and see if it exceeds this tension, this maximum tension. If it does, then what will happen to the performer is that if he is hanging stationary, he's going to break the rope and he will fall down. So we are given his mass. Just multiply this by gravity to find the value of the weight. And if we solve this, we're going to find that his weight will be 509.6 newtons, which is greater than the maximum tension. And here, of course, since he is hanging stationary, this means that the sum of forces should be 0, and then the weight is equal to the tension, which is equal to 509.6 newtons. So T is greater than the maximum tension that this rope can hold, and this means that the rope will break. In part B, we are told that at what magnitude of acceleration does the performer just avoid breaking the rope? So now we're looking for a situation where this performer is basically accelerating down the rope. He is sliding down now. He's not stationary. So in part A, we had stationary performer hanging to the rope. In part B, the performer is going to slide down. With acceleration A. And we are looking for a magnitude of acceleration that would just avoid breaking the rope. So we're basically looking for a value of tension in the rope just equal to the maximum tension. Now, if this person is sliding, we will have friction rather than tension. But the friction will be equal to the tension for the rope to be balanced and stretched. So we can just apply Newton's second law. The performer is sliding down, so I will take the downward direction to be the positive direction. So weight will be positive, the friction negative, the acceleration positive since he's sliding downwards, so his acceleration is downwards. And we are looking for the value of the acceleration. So the acceleration will be W minus F over M. We said this friction is equal to the tension itself. And the tension here, we want it to be just equal to the maximum tension because we're looking for the acceleration that will give us just avoiding the breakage of this rope. So we will substitute the value of the weight. We got it previously, 509.6, while the tension is equal to just the maximum value, which we are given to be 425 newtons, while the mass of the performer was given to be 52 kilograms. And this will give us an acceleration value of 1.63 meters per second squared. So we have this magnitude of the acceleration, and it is downwards, of course. So here we were able to study two situations for this performer. If he is stationary, the rope would break, while if he is immediately sliding down the rope, it's not going to break because he will leave his weight to be more than the tension that is exerted on the rope. So the tension exerted on the rope is going to be less, and thus we can avoid breakage despite the fact that his weight exceeds the value of the maximum tension.